Hello, good morning students and welcome back to a new video for the 9th standard. And today we are starting with a new chapter, Gravitation. So before starting the chapter, I would like to give some information about the new syllabus and the omitted topics. In this particular chapter, we had two topics, that is gravitation and flotation. In the second part of the chapter, that is flotation, we were going to study about buoyant force and thrust and pressure and everything. But in this topic, we are cancelling the buoyant force and the rest of the topics. So we are going to study till thrust and pressure, and before that, that is free fall and all the other topics of the gravitation. So we are going to study till thrust and pressure, and after that flotation part is being omitted, and not by me because it has been given the orders by the CBSE. You can check on the CBSE website and the topics. So the last topic that we are going to study from this chapter is till thrust and pressure. Okay? And the other thing is, the sound chapter has been completely omitted from the syllabus. Okay? So without wasting any more time, let's start with the chapter. Gravitation. Gravitation or gravitational force is the force that pulls the objects towards the earth. This is what we have studied. Okay? We experience gravitational force just like this marker. If I release it, it falls down. And any other object experiences the falling, or if we throw it to the sky, it comes back towards the earth. Okay? So this is gravitational force, and first time we studied this was in 8th standard. But if you remember perfectly, in 8th standard, the other thing that we studied was that if the two objects in the universe are somewhere closer to each other, they attract each other. Okay? So the gravitational force is not just the force of Earth which pulls all the objects, but it is actually, the gravitational force is universal force. The object, whether it is small or large, applies a force on the other object. Okay, so if I have another marker with me over here, let's say, then these two markers are applying force on each other. Okay, that is gravitational force. However, the force is not strong. That is why those two markers do not attract each other like a magnet. So gravitational force is a force, but it is not a very strong force. Okay. So why does the marker falls down, or how are we able to walk? All these questions will be answered in this chapter when we study gravitational force in detail. Okay. So if you remember, this was given by Isaac Newton. If you know, he was sitting under the apple. He was sitting under the apple tree, and the apple fell on his head, and that is how he tried and questioned the reason why the apple fell downwards. Okay, and then he got to a conclusion that there is a force which actually pulled the apple towards the earth, and that force is gravitational force. Okay. Now, for this particular thing, gravitational force, he gave a universal law about gravitational force. Okay. So this law, just like the first law of motion, second law of motion, and third law of motion, which were also given by Isaac Newton, the same thing, gravitational force also has a law, statement, which is also given by Sir Isaac Newton. The statement is that every object in the universe applies a force on the other object in such a way that it is directly proportional to the product of their masses, the mass of the two objects, and it is inversely proportional to the square of distance between them. So the gravitational force is force directly proportional to product of masses of those two objects. And it is inversely proportional to square of distance between them. Square of distance between them. Now let's understand the statement. Suppose have an object over here like this in an isolated system. This is object of mass m1 and this is object of mass m2. Okay? And the first statement, it is directly proportional to the product of masses. So let's say that this is the gravitational force. It is directly proportional to the product of masses. Product means multiplication. So m1 multiplied by m2. Okay? And the other statement, and it is inversely proportional to the square of distance. So these two objects have a distance between them, and the distance is measured by the center of the two objects. Let's say that this is the center of this object and this is the center of this object. Then the distance between them is taken for the line that joins the two centers of the objects. So this is the distance. Let's say that the distance is d. But it is not just the distance but the square of distance. So the next is f proportional to square of distance, but it says inversely proportional. So that is why we are writing it in reciprocal, that is 1 upon d square. So gravitational force is directly proportional to the product of masses and gravitational force is inversely proportional to the square of distance between them. So this is how these two statements are written from the universal law given by Newton. Okay. Now let's combine these two statements. So it becomes gravitational force F proportional to m1 m2 upon d square. Okay. This is how the statement described by the formula over here, that the gravitational force between the two objects is directly proportional to the product of the masses and it is inversely proportional to the square of distance between them, and the distance is taken from the center of the two objects. Okay, and the line that connects the two centers is taken as the distance. I repeat once again, the distance is taken from the center of the two objects and the line that connects the two centers is taken as the distance. Okay. Now once again, if you remember that proportionality sign is not the mathematical formula. So if we are going to find the gravitational force between any two objects, then this formula directly cannot be used. Okay, we have to convert it in the form of formula. This is just a relation. This is how force is dependent on masses of the two objects and it is dependent on the distance of the two objects. It depends, but not the actual formula. You cannot find force directly from this formula. Obviously, the force is dependent on these two. If any of these values change, then force will change. Okay, but it is not the final answer. So if you remember, when we found out force using the second law of motion, we did something like this, F proportional to ma. Okay, and when we remove the proportionality sign, we had F is equal to kma, where k is a constant. Okay, where k is a constant and the value of k is 1, and the value of k is 1. So we got the final answer as F is equal to 1 into ma, where F is equal to ma. This is how we found the value of or the formula of force. In this case, once again we are going to do the same thing, because whenever we remove the proportionality sign and convert it into a formula, there is always a constant that balances the equation. So in this case, we have F is equal to G into m1 m2 upon d square. Okay, where F is the gravitational force, G is a gravitational constant. G is gravitational constant. Okay, and its value was found out by the scientist Henry Cavendish. Okay, this is gravitational constant and its value remains always constant throughout the whole universe. Okay, I hope it is clear to you students. F is equal to G into m1 m2 upon d square. So the gravitational force is given by G into m1 m2 by d square, and the G is the gravitational constant which remains constant throughout the whole universe, and that is why it is also known as universal gravitational constant. The masses of the objects can change, but the value of gravitational constant will remain as it is, and its value is G is equal to 6.67 into 10 raised to minus 11. Okay, and this value is not 1 as you can see, just like before. So whenever you are finding the gravitational force between the two objects, you will have to use this value always, which is Newton meter square per kg square. This is the unit of the particular gravitational constant. Okay students, we'll talk more about this in the next video. Till then, have a nice day.